Hi, this class is to talk about steps of hypothesis testing when we have two population and we are testing two population means. Let me show you here. We're testing the difference in means of two populations when we know the population standard deviation. This is the second approach, which is the p-value approach. In the previous video, I worked on the critical value approach. This one is very similar to the first one, has very similar steps. Let's see the application in the same problem, training centers. We have a standardized examination and we want to know if the two centers are different, and then we get a sample size of 30 and 40 students in each training center, and then the means, and then we have their standard deviations. It's population standard deviation because it's based on previous studies. And here are the steps. Okay, I'm going to leave it here and then follow these steps here using this process. So let's take a look at the problem and see what the problem is asking. The problem is saying, can we conclude that no difference exists between the two training centers? So no difference is this one. No difference is equal. So it's a two-tail test. If no difference, then a difference is the alternative hypothesis. Okay, so let's work on that now. And then my first step is the hypothesis. So the mean for training center 1 is equal to the mean of training center 2, and they're different. Step number 2 is determine if there's one-tail or two-tail test. This is a two-tail test because of the hypothesis. It is equal or different. So that's a two-tail. Step number 3, let's take a look what my step. So develop the null alternative hypothesis, determine if it's upper, lower, or two-tail is a two-tail test, and then specify the level of significance. The level of significance is given in the problem. Here is alpha is 0.05. Alpha is 0.05. Okay, now the fourth step is collect the sample data and compute the value of the test statistic. So here is the data. So if I have to do the fourth step, would be z equal to sample size 1 minus sample size 2 divided by the square root of, let's take a look, my population standard deviation squared divided by the sample size of the first population, then the standard deviation of the second population squared divided by. So this is the formula to get the z statistic, and we have this done right here. So this is the z statistic. I'm not gonna do all the math. So if you do all the math, the answer is 1.66. Okay, so this is step number 4. And okay, I'm done. Find the probability of the z value also you found in step number 4. So what is the probability of this z statistic? So we have 3 cases: if it's lower tail or if it's upper tail. This case is a two-tail test, so I have to find the p-value for the lower tail and for the upper tail, and then choose the smallest and multiply by 2. So let's take a look. Let me see if I can open a file here and just use the file to get the p-value. Okay, so what my slides are saying is two-tail test. So find the p-value for the lower tail case and for the upper tail case. Okay, so in the case of two tails, what we have is a positive and a negative z-score. So this number here, this is a two-tail. because it's positive, that's positive, I know that is upper tail. So here is the probability value for the z-score, okay? And I'm going to use that to get the lower tail and the upper tail. Okay, let's do that. Okay, so I'm gonna find the probability value for the two cases. So if I use Excel and I follow I have norm equal norm s dist equal norm dot s dist. The z value is 1.66, and the you type comma and then cumulative 1 close parenthesis 0.95. This is the lower, and then let's do the upper. The upper tail is equal 1 minus the same thing we had above, so equal 1 minus this number here. So find 5.1 and 5.2, choose the smallest and multiply by 2. So the smallest is this upper here. Why? Because 1.66 is positive, is in the upper tail. This is the reason it is smaller. So what I'm going to do, I'm going to get this number and multiply by 2. This is what my slides are saying. Choose the smallest and multiply by 2. Okay, I get this is the p-value. This is the p-value. Okay. All right, so I have my p-value, and now compare the p-value you found in step 5 with the level of significance. So my level of p-value is 0.09. Let me put here. Oops. Step number 5, p-value is equal to 0.09. Step number 6, compare the p-value with the level of significance. If the p-value is smaller than the level of significance, you reject the null hypothesis. So the question is p-value smaller than 0.05? Is it smaller? No, it's not. No, it's not. It's not. 0.09 is higher, right? Than 0.05. So fail to reject the null hypothesis. Okay? So if the p-value is smaller, is not smaller, you reject. So if the p-value is smaller, if the p-value is 0.03, then you reject the null hypothesis. In this case, 0.09 is not smaller, so you fail to reject the null hypothesis. So the null hypothesis is the hypothesis that the two training centers have the same mean. Students from the two training centers have the same mean score, okay? So we fail to reject the null hypothesis, and this is the procedure to do that using the p-value approach. I have some slides here that go on that. You see 0.09, because p-value 0.09 is higher, we cannot reject the null hypothesis. All right, so this is the second approach, and in the next video I'm going to show another approach, which is using Excel when you have the raw data.